Hey guys, so today we are looking at section 2.4. So as you can see, we're actually getting into the sum and difference formulas in this section. So you have all the different formulas listed over here. So let's start with the first one. We've got sine of the quantity u plus v. So the way you actually break down this sum formula is actually it's going to be sine of u multiplied with cosine of v, and then you're basically switching the order, and then you have plus cosine of u multiplied with sine of v. So you can see it's sine u cosine v plus keeping the same sign as what we have in the left hand side, and then cosine u sine v. Now the only difference between the sum and the difference formula for the sine function is going to be that minus sign, because you will notice this is still sine u, this is still sine v like you had on the one above that, and then this guy is still cosine u and this guy is sine v. So if you remember the order of the sine and cosine functions, then all you need to remember is that one will be positive, one will be negative depending on which formula you are looking at. Sorry, and that's the same kind of thing that's going to happen with the cosine function. But for the cosine function, when you're looking at cosine of the quantity u plus v, you actually have cosine of u, cosine of v, right? So it's both cosines together. And then this one here is a sum rule, but you will notice we actually have a minus sign here. And then it's sine of u and sine of v. And then when you look at the cosine of u minus v, this guy of course has a plus sign here when we break it down. And then you still have cosine of u cosine of v plus sine of u sine of v, right? So they're actually pretty straightforward, but obviously it's important to make sure you keep track of what happens when you're using the sine function, what happens when you're using the cosine function. Now looking at our tangent, u plus v, so this one here is going to be as a fraction, so you can see it's tangent of u plus tangent of v on the top, and then on the denominator you have 1 minus the quantity tan u multiplied by tan v. So that's the rule for u plus v. When you have tangent of u minus v, this is where the signs in your numerator and denominator will change. So now this guy will become tangent of u minus tangent of v, and then denominator is 1 plus tangent u times tangent v. So you will notice when you have a plus sign on the left hand side, you have a plus sign in your numerator. When you have a minus sign on the left hand side, which is tangent u minus v, you're going to have a minus sign in the numerator of your tangent function formula, right? So basically you're switching the sides, as I said. So they're actually talking about, if you wanted to see why these rules work and what proofs they have, you can actually go to page 257 of your textbook, or if you just open the textbook page for this section 2.4, you can actually, so if you go to this section for 2.4, you can actually just click on this link here for the proofs in mathematics, and this little window pops up here, and then you can actually go down and look at these different proofs. So they're trying to show you how the left hand side will equal the right hand side and how these rules work out to be. So they have it broken down for all the different rules and stuff we will be looking at. So just something that I wanted to show you. Okay, so let's go back to our notes. So let's talk about how we can use these sum and different formulas to help us find the exact values of our trigonometric functions, especially if you can actually rewrite them to help us out. And basically they are saying these sum and different formulas can help you find the exact values of trigonometric functions that are involving sums or differences of special angles, right? So if we're talking about this special angle here, which is finding the exact value of sine of pi over 12, if you actually go and look at your unit circle, you will notice that we do not have a pi over 12 angle specifically mentioned here in our unit circle, right? So if you can actually rewrite that pi over 12 by using these angles that are given to us here in the unit circle, then it actually makes our calculation go a lot faster. So you will see here in the solution, we are taking the sine over 12, sine of pi over 12, and we are rewriting that pi over 12 as pi over 3 minus pi over 4, because think about it. If I take pi over 3 minus pi over 12, I find their common denominator, which of course will be 12. So I multiplied this side by 3, I multiplied this side by 4, and that ends up giving me 4 pi minus 3 pi over 12, and 4 pi minus 3 pi is of course 1 pi, so that ends up giving you pi over 12. So if you practice a little bit with these, you will actually start seeing how you can split up these angles. So here, by using this pi over 3 minus pi over 4, we are going to rewrite sine of pi over 12 as sine of pi over 3 minus pi over 4. And as it mentions here, once you rewrite it, you can actually go up and use the difference formula for the sine function, which was this second one over here. So now I can rewrite this as sine of u cosine of v minus cosine of u sine of v. So you can actually think of that pi over 3 as being our u function or u angle, and you can think of the pi over 4 as being the v angle, right? So breaking this down into sine of pi over 3 multiplied by cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. So really quickly, let's look at our unit circle here for these two angles, pi over 3 and pi over 4. So that would be pi over 3 here, pi over 4 here. So you're looking at the cosine and sine function. So that's going to be 1/2 square root of 3/2 square root of 2 over 2 square root of 2 over 2. So those are the numbers that we are using here. So square root of 3 over 2 multiplied by square root of 2 over 2, keeping that same minus sign from our formula, and then 1/2 times square root of 2 over 2. If you go ahead and combine all of these and simplify it, you actually end up getting this here, right? Because I am taking square root of 3, multiplying it by square root of 2, so that's where this square root of 6 is coming from. And then I am taking 1 times square root of 2, which gives me square root of 2. And then of course your denominator is 2 times 2, which is where the 4 is coming from. Now they are basically saying if you take your calculator and take this answer here, square root of 6 minus square root of 2, the entire thing divided by 4, the answer you get will be the same thing if you just plugged in sine of pi over 12 into your calculator. But you know, they're of course not asking us to find a decimal approximation. They are saying they want us to find the exact value of sine of pi over 12, so you don't want to use the calculator to solve this answer. Okay, so just to show you, when you do this on your calculator, this guy also comes out to be approximately 0.2588, and then it keeps going 19045. So if you round it to 4 decimal places, that comes out to be 0.2588, and so you will see that's the same answer if we just plugged in sine of pi over 12 in our calculator. And let me just verify that. Yeah, it comes out to be the same thing, 2.25881905. Okay, so this is for us finding the exact value, and the exact value is this one right here, square root of 6 minus square root of 2 divided by 4. And then the decimal answer, 0.2588, is your approximate answer. So just be careful about what they're asking us to find here, okay? So we're going to try and use this same idea for our problem here, and we are given find the exact value of cosine of pi over 12. So you can see this is the same angle pi over 12, so we will also go ahead and rewrite pi over 12 as pi over 3 minus pi over 4, just like they showed you in example 1, and use that in our example to break it down. So we're going to rewrite this guy as cosine of pi over 3 minus pi over 4. So you will end up actually using the second cosine rule, which is cosine of u minus v. So as you can see, that is cosine of u, cosine of v, plus sine of u, sine of v. So let's go ahead and write that down. This guy will become cosine of pi over 3 multiplied by, and you don't really have to write it like that if you don't want to, times cosine of pi over 4. Since this was minus, you will actually have a plus sign here. And then this will be sine of pi over 3 times sine of pi over 4. Okay. So your same angles, pi over 3, pi over 4, cosine of pi over 3 is 1/2. Cosine of pi over 4 is square root of 2 over 2. So let's go ahead and write that down. So 1/2 for cosine of pi over 3 and square root of 2 over 2 for cosine of pi over 4, and then plus, we'll go back to our unit circle. For sine of pi over 3, you have square root of 3 over 2, and then of course for sine of pi over 4, you have square root of 2 over 2. So square root of 3 over 2 for the sine of pi over 3, and square root of 2 over 2 for sine of pi over 4. If you multiply just the numerators, that will be 1 times square root of 2. So that's square root of 2, denominator would be 2 times 2, which is 4. Plus, when I multiply the right hand side, I'm multiplying square root of 3 with square root of 2, so that will become square root of 6 on the numerator, and then 2 times 2 will become 4. Since this is a common denominator 4, we can combine these guys together, and this will become square root of 2 plus square root of 6. So this is our exact answer. Now if you just wanted to know what the decimal approximation is for square root of 2 plus square root of 6, and then that whole thing divided by 4, it comes up to be approximately 0.965925826. And then if you just typed it in your calculator, cosine of pi over 12, well, cosine of pi over 12 also comes out to be the exact same thing, so rounded to 4 decimal places, it ends up becoming 0.9659. So you can see, even with decimal approximations, we can check your answer, but remember, this is just for checking. The square root of 2 plus square root of 6, the whole thing divided by 4, that's your exact answer, the one I have here in the red box. So that's what they are asking us to find. Okay? Alrighty. So now let's look at our next example here, and this is actually given to us in degrees, and they're asking us to find the exact value of cosine of 75 degrees. So again, you will see in our unit circle, we don't really have a 75 degrees given to us, right? So we won't be able to find the sine and cosine function just by looking at the unit circle. So this is where we again rewrite our 75 degree angle as 30 degree plus 45 degree, so that we can again go back to our unit circle. So using the cosine of u plus v formula, we'll rewrite 75 as 30 plus 45, and then that will give us cosine of 30 times cosine of 45 minus sine of 30 sine of 45, and then using the unit circle, we come up with these numbers, and these again add up to give you square root of 6 minus square root of 2, and the whole thing divided by 4. And just as a note, they are saying if you didn't see 75 as 30 plus 45, you could also rewrite 75 degrees and as 120 minus 45 degrees, and then instead of using the cosine u plus v formula, you could have used the cosine u minus v formula, and of course you should still get the same results. If you just wanted to do extra practice, you can try rewriting that 75 degrees as 120 minus 45 and see do you get the same result. Okay, so how about we look at example or problem number 2 for us, where they're asking us to find the exact value of, again, sine of 75. So we can rewrite that 75 degrees either as 30 degrees plus 45 degrees, or if you guys wanted to try it the other way, rewrite 75 as 120 degrees minus 45 degrees, and that will work for you also. So let's take a look at our example 2 over here. Sine of 75 degrees. We are going to rewrite 75 as 30 plus 45. Okay, so using the sine of u plus v formula, which is going to be this first one here, so that's sine u cosine v plus cosine u sine v. So let's go ahead and write this guy down. So sine of 30 degrees cosine of 45 degrees, and then this will be a plus sign because the sine function keeps the same sign what you have inside the parentheses, and then of course this guy will now become cosine of 30 degrees multiplied by sine of 45 degrees, right? So again, sine of 30 cosine of 45, sine of 30, which is this angle right here, is going to be 1/2. Cosine of 45 is going to be square root of 2 over 2. So let's write that down. Sine of 30, 1/2. Cosine of 45, square root of 2 over 2. Plus, for the other side, cosine of 30 is now going to be square root of 3 over 2, and then of course sine of 45 degrees is going to be your square root of 2 over 2. So this side will now become square root of 3 over 2, square root of 2 over 2. So again, when you multiply them across, 1 times square root of 2 is square root of 2, 2 times 2 is 4 on the denominator, and then square root of 3 times square root of 2 is going to become square root of 6, and then 2 times 2 is 4. Combine them together over the common denominator of 4. These guys will become square root of 2 plus square root of 6, and of course this will be our exact answer. Okay, so I hope this kind of shows you with both the radian angle like we did in example 1, or with the degree angle like we did here in example 2, that these formulas will work either way. Doesn't matter what unit your angle measurements are giving you in. Okay, so that was our problem number 2. Now let's take a look at a little bit of a different example here. So they're talking about evaluating a trigonometric function. They are saying find the exact value of sine of u plus v, and again you're finding the exact value. And what they're doing here is actually telling us what each of the individual functions are going to be. So they're telling us sine of u is equal to 4/5, and your angle u is basically a quadrant 1 angle, because value of u is going to be anywhere between 0 and pi halves. And then they're also telling us that cosine of v is negative 12 over 13. And this time our angle v is actually going to be in the second quadrant, which is going from pi halves to pi. Okay? So sine of u is given to us. We know u falls in quadrant 1. And then since this falls in quadrant 1, you can actually go ahead and calculate what your cosine of u is going to be. So they have actually used this little right triangle trigonometry here. So just think about it. If they are telling us sine of u equals 4/5, then sine is opposite over hypotenuse. So that's where the 4/5 is coming from. And then using the Pythagorean theorem, you can calculate the missing side, which of course comes out to be 3. So if you're talking about cosine of the u function, which is adjacent over hypotenuse, that will come out to be 3/5, right? So that's where they're getting this cosine of u is 3/5. And then using that same idea, we can take cosine of v equals negative 12 over 13. So this is where we are given cosine of v is negative 12 over 13, which is adjacent over hypotenuse. So that's your second quadrant. Cosine is 12 over 13. And since this is a second quadrant, we are going to ignore the negative sign for now, because we know cosine is negative in the second quadrant by default, right? So we don't really have to write that down. And then using your Pythagorean theorem, you can calculate the third missing sign. So now if we wanted to calculate what is sine of v, well, sine is opposite over hypotenuse. So using the second triangle, from angle v, your opposite side is 5 and your hypotenuse is 13, so 5/13. And you will see that's exactly what we had here. Sine of v equals 5/13. And then using your sine of u plus v sum formula, you can go ahead and write it down like this, then plug in your values for sine of u, cosine v, cosine u, sine of v, and then come up with your answer, which is negative 33/65 once you get done multiplying and adding these numbers, right? Okay, so let's try and use the same concept in our problem number 3. They are asking us to find the exact value for cosine of u plus v. They're giving us the sine function, again that's quadrant 1. And they are giving us the cosine of v function, and this is going to be in quadrant 2. So let's go ahead and take a look at how we can go about solving this. This was problem number 3. So let's go ahead and do our little triangles. Okay, so we know sine of u, or angle u, is in the first quadrant, so that's going to be our little triangle here. And let's say this is angle u. Sine is opposite over hypotenuse, so those would be your 12 and 3. And then using the Pythagorean theorem, go ahead and calculate the third side, which will end up being 13 square minus 12 square underneath the square root. And just going through our math, looks like that number comes out to be 5. So cosine of angle u would then be 5/13. So they're already giving us sine of u, and we know that's quadrant 1. And then they are giving us cosine of v, and we know this is quadrant 2, so that's why we're going to draw our quadrant 2 triangle. And they're telling us cosine. So cosine is adjacent over hypotenuse. And then of course to find the missing side, we can use the Pythagorean theorem to find that. So that will be square root of 5 squared minus 3 squared, and that actually comes out to be 4. So that means we are given cosine of v. So from this triangle you can find sine of v. Sine would be opposite over hypotenuse, so you would have 4/5. So we're going to need these when we finally calculate our values for the function here. So let's say we are given sine of u, which is 12 over 13. We know angle u is a quadrant 1 angle. So based on that, cosine of u comes out to be 5 over 13, right? And again, you can see the figure to help you out. Then the second information we were given in our problem was that cosine of v equals negative 3/5. We know angle v is quadrant 2 angle. So that means our sine of v came out to be 4/5. And again, you can kind of use that figure to help you out if you needed to. Now once we have these, we can get back to our original problem, which was finding the exact value of u plus v. Okay, so let's write down what that formula is. This is cosine of u, cosine of v, minus, because the cosine function changes the sign, minus sine of u, sine of u, and multiply that with sine of v. Okay, so let's see, cosine of u, and this is right here that I have written in black, or you can use the figure to help you out also. Cosine of u is going to be 5 over 13. Cosine of v was already given to us, so that's negative 3 over 5. Minus sine of u was given to us. I just found my typo. That should be 12 over 13, and I just wrote that incorrectly. So sine of u is 12 over 13, and sine of v we calculated out to be 4/5. So of course you need to multiply these numbers individually before you go ahead and subtract those two numbers. So this will come out to be 5 times negative 3 is negative 15. 13 times 5 is 65. Minus 12 times 4 is 48. 3 times 5 again. Sorry, 13 times 5 again will be 65. So now you have negative 15 minus 48. If you subtract those two numbers, of course your common denominator is 65, you end up getting negative 63 over 65, and this will be your exact answer. So this is what they are asking us for. So a lot of the information is given to you, and then like I showed you how you can come up with that missing information, and then using your sum formula for cosine of u plus v, you can come up with the exact value. Alrighty, so this was problem number 3 from our handout. Now let's look at this example 4 over here. This is talking about an application for the sum formula So they're asking us to write down cosine of arc tangent of 1 plus arc cosine of x as an algebraic expression. So here you can see this is again in the form of cosine of u plus v, right? So what they're doing is taking these individual functions, and they're going to use again a right triangle trigonometry to help us out. So using your cosine of u plus v formula, we're separating this into cosine of arctangent of 1, cosine of arctangent of cosine, minus sine of arctangent 1 times sine of arc cosine of x. So when you're talking about arctangent of 1, remember, if we say u equals arctangent of 1, then that means tangent of u equals 1, which would be opposite over adjacent. And then if we say v equals arc cosine of x, this will become cosine of v. Ooh. No, sorry, I wrote that wrong. Let me see if I can write this again. It should be cosine of v equals x over 1. So cosine is adjacent over hypotenuse, so that's what that will end up looking like. And then you can calculate our third missing side, and you can come into the play. So using those informations here, this first one will give us cosine, hold on a second. Yeah, because we are trying to find cosine of angle u, which will be 1 over square root of 2, which will actually end up becoming square root of 2 over 2, but looks like they actually didn't rationalize the denominator. They just left it as 1 over square root of 2. And then for cosine of the v function, they're coming to the second triangle, which would be x over 1, which just comes out to be x, and that's where this x is coming from. Right? And then of course using that same idea, you can do sine of u. Sine would be opposite over hypotenuse, so that's going to be 1 divided by square root of 2, so this guy again. And then for your second triangle, if you try to find out sine of v would be square root of 1 minus x squared over 1, which is basically just square root of 1 minus x squared. So that's where this guy comes from. And then of course they're multiplying everything and then rationalizing your denominator, which is where this answer is coming from. Square root of 2, x on the outside, minus square root of 2 minus 2x squared, and then of course the entire thing divided by 2. Now remember guys, they are asking us to find or rewrite this as algebraic expression, so this is kind of what they were asking us to find. Okay, so let's see how this will translate when we do our own example. And our own example is asking us for rewriting sine of arctangent of 1 plus arc cosine of x as an algebraic expression. So let's take a look at this guy here. So number 4. So just like we did in example 4, we're going to try and do the same thing here. So what I'm actually going to do is assign this the letter u, or angle u, or however you want to think about this. One second. And then I'm going to call this guy angle v. So you are basically saying u equals arctangent of 1 which of course using the definition of arctangent will now become tangent of u equals 1. Okay, and then the triangle for this guy, oops, that did not come out how I wanted it to. Okay, better. So this will be a 90 degree. So if this guy is your u, tangent is opposite over adjacent, so you can think of this as being 1 over 1. So if you find your Pythagorean theorem to find the missing side, this ends up being square root of 2 over 2. And we'll come back to that. And then for the second one, we are assigning the letter v to arc cosine of x. So again, using the reciprocal or the inverse functions, you will have cosine of v equals x over 1, because this is going to be for adjacent over hypotenuse. So again, if I do this as a triangle, let's say again this angle is our angle v, so cosine is going to be adjacent over hypotenuse, so that would be adjacent over hypotenuse. So using your Pythagorean theorem again, this guy will become 1 square minus x squared in the square root, or basically will end up becoming 1 minus x squared within the square root for your third side. Okay, so now if we wanted to use the addition rule for the sine function, this guy will come out to be sine of u let me get my handout so I'll make sure I don't mess this up. This will be sine of u plus v. So this will be sine of u cosine of v plus cosine of u sine of v, right? That's the formula. So let's see how that translates into this example here. So that's just our formula. So this guy will now be sine of u, that's that first part. So that'll be sine of arctangent of 1, and then cosine of arc cosine of x. Okay, and then for the second part, you're going to have a plus sign in the middle, and that will be cosine of arctangent of 1 multiplied by sine of arc cosine of x. Okay, so what will that come out to be? So remember, you're basically doing sine of u, cosine of v, sine of u, cosine of u. So sine of u, you are going to this first triangle here using u as our angle measurement. So sine would be opposite over hypotenuse. So that's opposite side from u is 1. The hypotenuse is square root of 2. So sine of u will become 1 divided by square root of 2, and you can rationalize that denominator if you want. And I'll come back to that. Then you're going to be doing cosine of arc cosine of x. So for cosine, for arc cosine of x, you are coming down to the second function here, v equals, or the second triangle, v equals arc cosine of x. So if I'm talking about cosine with respect to this angle v, cosine is adjacent over hypotenuse. So adjacent would be x, hypotenuse would be 1. Then your missing side, of course, would be the 1 minus x squared, the whole thing under a square root. Okay. Cosine of u, which means the above triangle. So cosine of u would again be adjacent over hypotenuse. And then the sine of arc cosine of x, which is the second triangle, will end up becoming the sine 11 over, sorry, 1 over x? No, I did that wrong. Sine of arc cosine, so that's the second one. Sorry, that's opposite over hypotenuse, so this will be square root of 1 minus x squared over 1. So use these two triangles to help you come up with what these function values are going to be, because honestly I think that's going to be your easiest way of doing that. Now what I actually do prefer, whoa, what happened? There we go. I actually do prefer to rationalize my denominators first. Oh, looks like I lost that. So I would actually go ahead and multiply both my numerator and denominator by square root of 2 and do the same thing here. So I would actually end up getting square root of 2 over 2 multiplied by x over 1 plus square root of 2 over 2 multiplied by 1 minus x squared inside that square root. So multiply your numerators, multiply your denominators, and that will come out to be x times square root of 2, and then 2 times 1 on the denominator, plus in here you will actually need to distribute this square root of 2 inside the square root of 1 minus x squared, and then just multiply the denominators, and this will actually end up giving you square root of 2 minus 2x squared, and then 1 times 2 on the denominator will be 2. You can put it all together over a common numerator, and this whole thing is your exact answer that we are looking for. So it can take just a little bit of work to get through this, but if you look through these steps, they're not hard. They just take a little bit of calculation to go through, but you will definitely come up with your answer for this guy. So this was your problem number 4. So as you can see, these are all different applications using this sum and difference formulas, right, from this section. I'm just trying to show you how you can either rewrite these expressions, write them in algebraic form, or just kind of try to find your exact answers. So in that same way, let's see how we can use the sum and difference formulas to verify a cofunction identity. So looking at example 5, you can see we are given cosine of pi halves minus x, and we just have to basically show that it will in fact simplify into sine of x. So you can think of this as being your angle u, this is angle v, and we're using the formula cosine of u minus v. So using that rule, we break down our right hand side like this. Cosine of pi halves, that's your 90-degree angle, so your cosine is 0 at that point. Cosine of x stays the same, but we know 0 times cosine of x will end up becoming 0, so that first term becomes 0, and then sine of pi halves will become 1, sine of x will stay sine of x, so that's where your sine of x gets left behind, and then 0 plus sine of x will of course end up giving you sine of x. So that's again pretty straightforward how you can see that verification happens. So problem number 5, we have about a similar kind of thing. We are given sine of x minus pi half. So that's the cofunction we are given, and we have to verify that it's going to equal negative cosine of x. Okay, so if we're talking about verify, then we don't know these guys are equal till you can show that they are equal. Okay. Alright, so problem number 5. We are given sine of x minus pi halves, and we have to show it's going to equal negative cosine of x. So let's start on the left hand side. Again, you can think of this as being u minus v format. So if you're using sine, okay, sine of u minus v, that will come out to be sine of u cosine of v minus cosine of u sine of v. So using this, let's rewrite number 5. Okay, so if you are given sine of x minus pi, this will become sine of x cosine of pi halves, keeping the minus sign. Then this will become cosine of x and sine of pi halves. So just a quick circle. This here is your pi halves. So those are going to be the ordered pairs 0, 1. So sine of x, of course, will stay as it is. Cosine of pi halves will become 0, minus cosine of x will stay as it is. That's not how I want to write that. Okay, cosine of x will stay as it is, and then sine of pi halves will of course become 1. So 0 times sine of x, 0 times anything is 0, so this ends up becoming 0, and then cosine of x multiplied by 1 will of course be just cosine of x, so you end up getting 0 minus cosine of x, which ends up giving you negative cosine of x, and now we can say we have verified this cofunction identity, and we can show that it will equal negative cosine of x. So it's not too bad, like I said. Just make sure you're using the rules properly and correctly. Okay? The another place where we can use these sum and difference formulas is also to derive our reduction formulas. So they are basically saying, if you have expressions like this, sine of theta plus n pi over 2, or you have cosine of theta plus n pi over 2, where your n is an integer, you can actually just rewrite them as trig functions only with theta, which means you can get rid of this n pi over 2 from both our examples. So the sum and difference formulas actually come in handy also for those kind of examples. So let's look at number 6 over here. We've got for part A, cosine of theta minus 3 pi halves. So as a simplified form, you can see we're using the cosine of u minus v. So that's cosine of theta, cosine of 3 pi halves, plus sine of theta, sine of 3 pi halves. Again, your sine of 3 pi halves is going to be this angle right here. So this again will have the ordered pair of 0, negative 1. And so you can see that's where your cosine of 3 pi halves becomes 0, and sine of 3 pi halves becomes negative 1. So cosine times 0 will become 0, and you're left behind with negative sine of theta. So you can basically say that this guy is going to be the same as negative sine of theta, but now you're not writing this big expression, right? You can just write it as a single trigonometric function with theta on it. And in that same way, you can actually use the part B here, tangent of theta plus 3 pi, and use the tangent formulas to break this down. So this guy breaks down into tangent theta plus tangent of 3 pi divided by 1 minus tangent of theta and tangent of 3 pi. So if you again think about your unit circle here, pi is going to be right here, 2 pi is here, which means this guy can also be 3 pi. So for 3 pi, you are at the ordered pair negative 1, 0. So that's why tangent of 3 pi is going to be 0. Tangent of 3 pi is going to be 0. And when you clean this up, you end up getting just tangent of theta, right? So this guy is the same thing as tangent of theta. So you can use these sum and difference formulas to kind of condense or reduce your expression here. So let's take a look at our examples. Same thing, we write the expressions only as trig functions in theta. So for part A, we are given sine of 3 pi halves minus theta. So let's take a look at this guy. So this was 6a. So you can of course use the sine of u minus v formula here, which would be sine of u cosine of v minus cosine of u sine of v. So rewriting this, I get sine of 3 pi halves and cosine of theta minus cosine of 3 pi halves and sine of theta. So you're still talking about the angle measurement 3 pi halves, which is still going to be this point here. So that will have the ordered pair 0, negative 1. So sine of 3 pi halves is negative 1, and we're multiplying that with cosine of theta minus cosine of 3 pi halves is going to be 0, and you're multiplying that with sine of theta. So these guys here will end up becoming basically negative 1 times cosine of theta. That just becomes negative cosine of theta. And then here, 0 times anything is 0. So that's minus 0. And of course, that just leads you to cosine of theta with a leading negative sign. So negative cosine of theta. So this is how you can rewrite part A in just terms of theta. And of course, in that same way, we can work through part B. So part B, you are given tangent of theta minus pi over 4. So tangent of theta minus pi over 4. And I'm actually going to go back to the very first page of this handout to show you the tangent rule. So you're actually looking at this guy over here, tangent of u minus v, which is equal to tangent of u minus tangent of v, the entire thing divided by 1 plus tangent theta, tangent pi over 4. So the rule here is tangent of u minus v, which comes out to be tangent of u minus tangent of v divided by 1 plus tangent of u tangent of v. Okay, so that's the formula. So for us, that will become tangent of theta minus tangent of pi over 4 divided by 1 plus tangent of theta tangent of pi over 4. So tangent of pi over 4, do you know what angle that's going to be? Again, you guys of course have your unit circles. That's going to be this angle here, pi over 4, which is the same of course as 45-degree angle. So remember, these are the ordered pairs, square root of 2 over 2 and square root of 2 over 2, right? Same cosine and sine values. So tangent theta of course will stay as it is, minus tangent pi over 4. So if you think about it, if I'm taking the tangent of pi over 4, that means I'm dividing square root of 2 over 2 by the same number, square root of 2 over 2. So dividing the same number by itself will end up giving us 1 here. So tangent of pi over 4 actually comes out to be 1. So that's where this 1 is coming from. Then in our formula, we are given 1 plus tangent of theta will stay the same, but then again tangent of pi over 4 ends up becoming 1. So you are going to end up getting tangent theta minus 1 over 1 plus tangent theta. You can leave it like this if you want, but normally we actually clean this up, and you can write this as tangent theta minus 1 over tangent theta plus 1. So I'm actually just taking this 1 plus tangent theta and rewriting it. Now you can't really do a whole lot at this point, because unlike your example here, like we did in example 6a and 6b, it really doesn't clean up into something. So for here, our problem number 6b, you are just going to leave it like this. So tangent of theta minus 1 over tangent of theta plus 1. Okay, that's going to be our answer for 6b. Now, we're almost to the end of this handout now. So now they are asking us to solve this trigonometric equation. They're asking us to find all the solutions for sine of x plus pi over 4 plus sine of x minus pi over 4 equals negative 1. And they want us to stay within the interval 0 to 2 pi, right? So what they have done is they have used the sine of u plus v and the sine of u minus v formulas here to help you break this down. So this is cosine of sine of x, cosine of pi plus 4, and then cosine of x and sine of pi plus 4. This part here is coming from this first part, and then sine of x, cosine of pi over 4 minus 4, and then minus cosine of x, sine of pi over 4 is coming from this second part, and you're of course setting it equal to negative 1. Clean this up, combine your like terms, you're going to end up getting the second step. Cosine of pi over 4 is of course your 45-degree angle, so that's where the square root of 2 is coming from. Sine of x will stay the same. Go ahead and clean this up, get your sine of x by itself, and you end up getting sine of x equals negative square root of 2 over 2. And this is kind of what we were doing in the last section. So just go to your unit circle and find out where is the sine of x function going to be negative square root of 2 over 2. And sine of x is going to be negative square root of 2 right here. So that's angle 5 pi over 4. And it's also going to be right here, negative square root of 2 over 2, which is angle 7 pi over 4. So that's where they're getting this 5 pi over 4 and 7 pi over 4. So just another way to use the sum in different formulas. So let's try and see how we can break that down for our problem number 7. We are given sine of x plus pi over 2, and that is being added to sine of x minus 3 pi over 2, and that equals 1. And again, we are also staying within the interval from 0 to 2 pi. So this one here is going to be your u plus v formula. This guy here is going to be u minus v formula. So let's see how we can write this down. This guy will be sine of x cosine of pi halves plus, cosine of x and sine of pi halves. This is coming from this first term over here. Then for the u minus v, you will have sine of x cosine of 3 pi halves minus cosine of x times sine of 3 pi halves, and this should equal 1 on the other side. So, do we have any like terms in there? I don't think so, because these guys have angles pi halves. These guys here have angles 3 pi halves. So let's just use our unit circle here to help us out. So let me do a rough sketch here. We have angles pi half, which will be this 90-degree angle here. So that's the ordered pair 0, positive 1. And then our second angle, 3 pi halves, will be at 270 degrees. And this will have the ordered pair 0, minus 1. So when we write these guys, you will end up getting sine of x, and then cosine of pi halves is going to be, what did I do? Is going to be 0 plus cosine of x, and sine of pi halves will be positive 1. Okay. And then let's see, we will have from the second part here sine of x, and then cosine of 3 pi halves will also be 0 minus cosine of x, and sine of 3 pi halves is now going to be negative 1. And right hand side we still have a positive 1. So these guys here will become 0. This will also become 0. So then you are left with cosine of x times 1 is cosine minus cosine of x times, well actually that's not going to be a minus. Because we are multiplying negative cosine of x with negative 1, so negative times negative will actually become a positive cosine of x. We still have 1 on the right hand side, so you're adding cosine with cosine. That will be 2 cosine of x. To get cosine of x by itself, go ahead and divide both sides by 2. And you end up getting cosine of x equals 1/2. So you basically have to find out x will be what angle. So go to your unit circle and see where your cosine function is going to be positive 1/2. So cosine function is positive 1/2 at pi over 3, and cosine function is positive 1/2 at angles 5 pi over 3. So this will be true when x equals pi over 3 and x equals 5 pi over 3. And this is of course in the interval 2 pi, including 0 but not including 2 pi. Right, so that's what they were asking us to do, is find these angles where we could come up with these answers. So that was finding the solutions for this. Okay? And we had done something similar to these examples in our last section, but of course the formulas here are different. We were using trig identities there, and here we're using these sum and difference formulas. Now this last example here, as you can see, is talking about being an application from our calculus courses. So an application from calculus, they are asking us to verify that sine of x plus h minus sine of x, the whole thing divided by h, will equal this right hand side. So on the numerator part, we are actually starting out with sine of u plus v. So this little part here is coming from sine of u plus v. So that's sine x cosine h plus cosine h sine h minus cosine of x divided by h. Then what they are doing here is basically between, let me see if I can show you this, they are taking this function here in the numerator and this one together and factoring out your sine of x. So that leaves us with 1 minus cosine of h. And then keeping this term as it is. They haven't changed this. This is from the step above. Denominator is still h. And then using this minus sign here, they are separating the two halves. So I know it's a little tricky to see this in example 8, but we're doing pretty much a similar kind of thing here with our problem number 8. So let me show you how we can go from the left-hand side to right-hand side. So for this part here, you are going to be using the formula for cosine of u plus v to break this down. So let's take a look at this guy here. Okay, so we are given the left-hand side. And we have to show what happens and how can we get the right-hand side. So use the u plus v formula. So that would be cosine of x, cosine of h, and then for the cosine formula you actually switch your signs. If it's minus in the formula, this guy will become plus. And then here I will have sine of x multiplied with sine of h. So this is how you would go ahead and rewrite this little term. Then you still have minus cosine of x on that right hand side. We're still dividing the entire thing by our original denominator, h. But now we gotta separate these guys, right? So I'm actually going to go ahead and write this down without those square brackets. So I'm going to write this down as cosine of x, cosine of h, plus sine of x, sine of h, minus cosine of x, the entire thing over h. So you can see this term here has a cosine of x in it. This term here has a cosine of x in it. So let's get them together. So now you can write this as cosine of x, cosine of h, minus cosine of x. And then I'm going to take our sine x, sine h term and put it at the end. And we're still dividing the entire thing by h. Now, we've got a cosine of x here, we have a cosine of x here. Let's factor that out. So So from the first term, if I factor out the cosine of x, I still have this cosine of h left behind, right? So we still want to write that cosine of h, and then minus sign, the same sign we're keeping from here. And then since I'm taking this cosine of h outside, I'm going to put a placeholder for it and make it 1. Okay? And then, hold on a second, I think I just realized what I did. This was cosine of x plus h, so this actually here should be a minus sign. This should be a minus sign. And this should be a minus sign. So I actually did not change my sign like I was supposed to. Alright, so we factored out our cosine of x. We are left with cosine of h minus 1 here, and then bring down that last term, which will be minus sine of x, sine of h. And this entire thing is still divided by h. Now remember, we're trying to verify this identity, so we're just trying to make that left-hand side look like the right-hand side which was given to us, and you're actually almost there now. So now, I have cosine of x, cosine of h, minus 1, right? I can separate that and give it its own denominator of h, and then using this minus sign here, I'm going to separate my two fractions. So I'm going to put that minus sign here, and then I'm going to write sine of x, sine of h, and this was also with the denominator of h, so I'm just kind of splitting up my denominator into those two places. And just to get it to look more like the right-hand side of what they're asking us to verify, you can write cosine of x on the side, and then you can write cosine of h minus 1 over h here. Because this is multiplication here, right, you can go ahead and separate these like the way I did. If it wasn't multiplication, then of course we couldn't have done that. And that's the same thing that's going to happen here with the sine x, sine h. You can write this as sine of x on the side, and then in parentheses we can have sine of h over h. And of course, since we are dividing by h in our expression here, we don't want that h to equal 0, because otherwise that's where you get undefined functions. So this is how you have to be careful. Just follow those steps, and you can go ahead and show how you verified your trigonometric expression over here. So I hope you can kind of follow this step by step and see how we came up with this answer. Okay, so this was our section 2.4. So I hope you can kind of see how the sum and difference formulas work out. And then again, if you have any questions about any of these examples, let me know, and we can talk about these in class. Alright guys, so be careful, and I will see you in class next time. So have a great day. Alright guys, bye bye.